We're going to look at the quadratic function in the form of a basketball problem. So we're going to watch a video first and get some information and see if we can use that information to make some calculations. So here's the video.
I'm Elton Brand. I'm a power forward in the NBA. I'm here in my hometown, Peekskill, New York, visiting my old high school. I started playing basketball when I was about 5, 6 years old, and I was really, really bad. But learned the game and kept working at it and got better and better as I got older. I started out high school on the junior varsity team. Then the coach from the varsity team brought me up to that level. The following 2 years, we won the New York State Championship, which put me on the national spotlight and my team. So after high school, I accepted a scholarship to Duke University, got to college and played really, really well and became the #1 pick out of all the collegiate players and got drafted by the Chicago Bulls #1 overall. And it was a dream come true. As anyone that follows sports statistics knows, there's a lot of math in basketball. Free throw shooting is a skill that every basketball player has to work on. I don't constantly think about the math behind it when I'm playing a game. But when I was younger, understanding math helped me improve my performance. 3 key variables can influence your shot. First is the release height. Second is the ball's initial vertical velocity, a rate that includes the angle and speed of the ball as it leaves your hand. And the third is gravity, which makes a basketball accelerate as it falls. You can use these variables to figure out the height of the ball at any given time. And knowing that, you can tell if you'll make the shot. When I shoot a free throw, my goal is to maximize the height of the ball so it has the best chance of going in. Your challenge is to use the 3 key variables and my stats to figure out the maximum height the ball reaches on its way into the basket. At release, my average initial vertical velocity is 24 feet per second. My average release height is 7 feet. The free throw line is 15 feet from the backboard. The height of the basketball hoop is 10 feet off the floor, and the rim is 18 inches in diameter. And finally, you can find the height of the ball at each point in time by combining the 3 key variables. The acceleration of gravity, which is -32 t squared, but in this case, you'd use only half for downward pull, or -16 t squared. The initial vertical velocity, which you'd multiply by time to get the distance traveled, and the release height. All right, get to work.
All right, so let's put those in. Here is numbers and his equation. And we'll sketch a graph of what this looks like. So the acceleration of gravity is downward at -16 t squared. His initial vertical velocity was 24 times t, and then his release height was 7 feet. So we put that all together to make this equation. -16 t squared plus 24t plus 7. Let's draw a situation of what this looks like. Whoops. And talk about like the key points of this problem. Okay, so let's say here he is shooting that basketball. Here's his ball. Here's the basket. Okay, so he takes a shot, it's going to go up and then go down. All right, so there's key points to this right here. His release height, we have this vertex right here. And then we have when the ball hits the ground. Okay, so this would be a 0 or an x-intercept. It's when the height is 0. The vertex, 2 key points, x, y. And x is the time it takes to reach that point. And y would be the height at that point. So there's our drawing. And it's going to ask us 3 questions. So the first one is, plan it out. At what time does the ball reach 10 feet? Okay, so if we go back, at what time does the ball reach 10 feet? So here he starts his y-intercept here His starting value would be at 7 feet. So it's going to go up to 10 feet. And it's actually going to hit 10 feet twice. Let's see if I can draw a straight line here. Okay, so here's the basket at 10 feet, and you can see that that ball is at 7 feet. It goes up, it hits 10 feet the first time, reaches its highest point, and then reaches 10 feet again before it goes down and hits the ground. So it says, what strategy will you use to calculate the value of t when the ball reaches a height of 10 feet? So what we can do really is we're looking for these 2 points, and if we considered this blue line the x-axis, these would be finding the zeros. Okay, so if you write this equation out, and that was this negative 16t, here's his equation. His height at any given time is negative 16t squared plus his 24t plus 7. We want to know, when does that height reach 10 feet? But if we look at the graph, if we want to find the x-intercepts here, we need 0 on one side, and then we can use quadratic formula. So let's do that. Let's subtract 10 from each side. Let's get 0 on one side. That'll equal negative 16t squared plus 24t minus 3. And now we can solve this to find the zeros. Again, if this is our picture and we want to see when it reaches 10 feet, we can use quadratic formula. Okay, so let's do that. Let's use quadratic formula with this equation to find the zeros of that graph. Solve your problem, show your steps. Okay, so let's first find A, B, and C. So according to our equation, A was negative 16, B was the 24, C was the negative 3. We got from getting 0 on one side here. Okay, let's plug in a quadratic formula. X equals opposite B, so negative 24, plus or minus the square root of b squared minus 4ac all over 2a. I want you to calculate these 3 numbers right here. The first number, the discriminant, this number underneath, and we get x equals negative 24 plus or minus the square root of, let's type this in. So we have 24 squared minus 4 parentheses negative 16 parentheses negative 3. All right, so that's 384. All of this over negative 32, 2a. And then we can split it up and solve it. So I'll do the plus first. Negative 24 plus the square root of 384. I'll hit enter. Divide by our negative 32. So here's our first answer after 0.13, I'll run a 0.14 seconds. The ball will hit 10 feet first. So that would be the first 10 feet that it hits, and then it's going to travel up and it's going to hit 10 feet again. So that's the number we're looking for. When does it hit the basket? So let's do negative 24 minus the square root of 384. Divide by negative 32. And here's the second time it hits the basket after 1.36 seconds. Yeah, 1.36 seconds. All right, so this is when it will hit the basket. Here's the first time it hits 10 feet. So you can use quadratic formula to find when it hits 10 feet, but you do need to get 0 on one side first. Okay, so the 2 times that the ball reaches, and we had them written right here, 0.14 and 1.36 seconds. So now it says, how can you use the same thing on the calculator? All right, well, let's open a graph page. And let's type in our type it in our equation right here, negative 16. And we have x squared, so on this calculator you can't use a t, you have to use an x. Plus 24x minus 3. And we can see these two spots right here. If you want to actually calculate, you can go to Menu, Analyze Graph, and we're looking for the zeros. Go to the left and the right of your zeros. There's that first time it hits the basket. And then Menu, Analyze Graph, 0. And here's that second time it hits the basket, 1.36. So a quadratic formula to find when it hits the basket at 10 feet, we get 0 on one side first. So the next type of question is, at what time does the ball reach its maximum height? Okay, so again, if we go back to our picture right here, what time does it reach its max height? Its max height is the vertex. And the time that it takes to reach that vertex is the x value. So if you remember, to find the vertex, there's a few ways to do it, but we can do x equals opposite b over 2a. So if we look at our equation, we're going to go look back at the original equation here. So this is the original equation. The b value is 24. So let's write that in. So this equals negative 24 over 2a, and a is negative 16. Excuse me, negative 16. So we have negative 24 over negative 32. Let's see what that equals. Negative 24 divided by negative 32. All right, so after 0.75 seconds, at 0.75 seconds, it reaches its maximum height. So we found the x value. So time, when it reaches its maximum height, is the x value. But now if we want the height, let's go back to see what it asks us here. So it says, what's your answer? So the ball will reach its maximum height after 0.75 seconds. What is the maximum height? Well, that's the y value. So we have this equation, negative 16t squared plus 24t plus 7. And we have the time that it reaches its max height. So we're going to plug that in here and in here. So our strategy, I'll put my work up here, is y equals negative 16 times 0.75 squared plus 24 times 0.75 plus 7. So we're going to type that in our calculator here. We'll use parentheses when we type it in. All right, so here's what it'll look like. Negative 16 and then we have our 0.75 squared plus 24 times 0.75 plus his initial height at 7 feet. All right, so here's the max height at 0.75 seconds, 16 feet. So let's write that down. So y equals 16 feet. So once you find the time, plug that in, and then you can find the height at that time. So in this case, 16 feet, it reaches its maximum height. All right, so 16. It says show how you could find max height and time on the calculator. Well, again, type it in. Let's go to the graph. Type it in. So again, it was negative 16. Negative here. Instead of x, t, we'll put an x. Plus 24x plus 7. And if we want the maximum height, we already knew the zeros or where it hit the ground. But here's the maximum height. So we're going to go to Menu, Analyze Graph, and we want maximum. And you can see at 0.75 seconds, the height is 16 feet. So you can use your calculator to graph. All right, last problem. When does the ball reach the ground? Okay, so again, if it's the ground, you throw the ball up and it goes down. We're looking for the zeros. And we're going to get 2 of them here, but one's going to be negative because the initial release height was 7 feet. So really, we're looking for this guy right here. So to find the zeros, we can use quadratic formula. And if you remember A, B, and C, so we look at the original equation. A is negative 16, B is 24, and C is starts at 7 feet. And so when we type this in, we get x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So I'd want to see this plugged in right here. Oops, it should not be. right, let's get our three numbers, this negative 24, the discriminant, and then negative 16. All right, let's type this in. So we got 24 squared minus 4 times negative 16 times 2. Okay, so 704 all over negative 32. And let's calculate our two answers. So negative 24. Oh, did I put 2 here? I should have put a 7 there. So let's redo this. 24 squared minus 4 parentheses negative 16 parentheses, and C was 7. Okay, 1024. Let's erase this. Okay, so let's calculate our numbers. Negative 24 plus the square root of 1024, we'll hit enter, and divide by negative 32. So this is negative 0.25. So that is, if we look at our picture here, this negative number, which in this case doesn't make sense. So let's get the other value. So it'll be negative 24 minus the square root of 1024. Hit enter, divide by negative 32. All right, so after 1.75 seconds, it will reach the ground at a height of 0. And again, we calculated the zeros with quadratic formula. So 1.75 seconds. Okay, so on your assignment today, you have to ask yourself, am I looking for the zeros? Then use quadratic formula, or do I want the vertex, the highest point? If it's the highest point, we're going to use opposite b over 2a and then plug in and find the y value.